Morning, Mr. Bergman. How is it going?
It's going great, Mr. Dmitrich. How are you doing?
I can't complain. Just to get to know you a little bit better, why don't you tell us how you met your wife?
Well, I met my wife at church. Well, the story goes that she showed up at the church, and I had just been at the church for just a little bit, and then she shows up, and then they kind of singles group. And one time we went shopping, and like I did a handstand in the shopping place. We weren't seeing each other like that, and she thought, "There's no way I could ever marry that guy. He's just weird." And long story short, it was about 2 years later that we really decided that we were special to each other. So it was like 2 year friendship. We'd play racquetball, and eventually we realized that there was something more. How about yourself?
Actually, I met my wife at my former school. I was speaking Spanish in the hallway, and she was a Spanish teacher, and she was like, who's that guy? And yeah, things kind of progressed, and true story. But moral of the story is that no high school students should ever date, though, right?
Yeah, yeah. Well, high school students. I mean, what's true about all high school romances?
They're terrible and end horribly.
Yeah, I just say they always end. So that's what I was going to say. But yeah, they usually end horribly. Yeah. So yeah, students, maybe not such a good idea. Hey, today, guys, we want to talk about an idea called this: dimensional analysis. So, Mr. Dmitrich, what is dimensional analysis?
Well, dimension analysis is a way that we can convert from one unit to another.
So we say here a way to determine quantities, right? And because it leads us, and it's also called a couple other things. What else is it called? Now you got kind of a cool name to me, Mr. Mijwich.
Well, I'm weird this way. I call it table o death with a little apostrophe as if it's Irish, because it's death to the units we don't want. But we also call it unit cancellation. I think that's a little bit easier way of saying it.
So the idea is to kill units, right? Table of death, or cancel units, because it's actually a mathematical thing that we're trying to do as we cancel our units. And a key term that's really important is this thing called a conversion factor. What's a conversion factor?
Well, the way I look at it, and the easiest way to think of it is anytime you have two things that are equal to each other, that's a conversion factor. So, for example, if I say 1 foot is equal to 12 inches, that is a conversion factor, which means if we know how many of one of the things we have, we know how many of the other things we get.
And I want you to make a note here, folks, is we're going to actually write this. We're going to always write our conversion factors. Write this down, right? You're going to write them as a fraction, and you'll see what that looks like in just a minute. And now what we're going to do is I'm going to jot down what we're going to call the steps. There are a series of steps to solve when you are doing dimensional analysis, unit cancellation problems, conversion problems, I guess what you have. So I'm going to just write these down, and I want you to copy them down. So here we have them. You're going to write the given amount as fractions, right? And if there's only one dimension, like just 1 meter or 28.4 meters, something like that, you write it as a fraction over 1. Then you choose your conversion factors from the table. We're going to share a table in just a minute. You're going to write conversion factors in order to cancel the unit. That's where you have to choose to flip them upside down or right side up. And you're going to cancel out the units until you get the desired unit, or sometimes plural units. And lastly, all the numbers on the top you multiply, and all the numbers divide. This probably doesn't make a whole lot of sense until you really do some examples. What say you, Mr. Dmitrovich?
Yeah, we need to practice these a little bit, and all the things that you said, although it may sound a little bit weird right now, it will totally click into place. Promise.
Cool. So guys, what we want to do now is we're going to do some examples. So the first example is we're going to take 2.4 miles and we're going to convert it into feet. Now in your handout, in your notes handout, there is a conversion table. And so that's something you want to use. It looks like this. And yeah, now, Mr. Dmitrich, what do I need to do when I first step? I've got 2.4 miles, but I'm going to rewrite that as what?
Well, you're going to put it in as a fraction in your table above 1, but there's no real need to put it as 1. I mean, you can get away without doing it if you want to.
Yeah, but this helps. I don't know. I think it's important that you do it, students, because if you do this, then it creates this what we're going to call the railroad track method. So you keep everything in alignment. Now, I want to go from miles to feet. Now, this is relatively easy. If you look at your conversion table, there is a conversion from miles to feet. Important. We've got miles on top, guys. So this is now we have to make a decision because we've got 5,280 feet over 1 mile. Remember, we're going to write this as a fraction, but I could just as well write this as 1 mile over 5,280 feet. Now, which way am I going to write this? The first way or the second way? With the miles on the bottom or the miles on top? What would you do, Mr. Dimitrich?
Well, it depends on what you want to cancel. And this is a principle from math that we know from before. Since
Yeah.
miles is on the top, we want to cancel it out. And in order to cancel it out, we have to put the unit we want to cancel opposite it.
So now notice what I did. I actually didn't even worry about the numbers. I just put the units here first. Now I go back and I find the number. 1 mile is 5,280 feet. Now the next step is I cancel the miles, and guess what I have left? I simply have feet. Now to calculate, remember, if all these numbers are on top, 24 or 2.4, pardon me, and the 5,280 feet, and I just multiply the two together, and I get 12,672 feet. Now we should sort of make a note. We have talked about significant figures here before. Since this measurement is 2.4 miles, how would I round this? I would have to round this to how many significant digits?
Well, remember, whenever we're doing multiplying or dividing, we always take the least number of significant figures.
So that's going to be 2 significant digits. Yeah. So the number is going to be 13,000 feet, because the 6 rounds the 2 up, and it's just, and we just add zeros to the end. Make sense? So that's the first example. We got 2 more.
So you mentioned we talked about having the least number of significant figures. What about the 1 mile and the 5,280 feet? We ignored that one.
Well, because actually this is the definition of a mile, that it's exactly 5,280 feet. So this is actually 5,280.000. It's an infinite number of significant digits. That isn't true in all of our conversions. For example, again, looking at the conversion table over here, we've got 2.54 centimeters is equal to 1 inch. And that's actually just an approximation. That's actually just 3 significant digits in that conversion. Usually what you see is when you're going from one system to the next, from say the metric system to the English imperial system, that those are you have to use those as significant digits. But if I say, for example, there's 1,000 milliliters in 1 liter, that's the definition of a milliliter. So there's an infinite number of significant digits. The next one we want to do is we're going to do this: 112 miles into centimeters. Now, this is a little bit more complex because if you look at the conversion table, there's no miles to centimeters conversion. So we need to kind of plan this out. So given what we have on this table, what could we do, Mr. Dimitrich? From miles, what could I go from miles to what?
Well, we can go from miles to feet.
Let's go to feet.
And then feet to inches, perhaps?
Feet to inches, and then inches to centimeter.
Yeah, so you have to do it in multiple steps.
All right, so 112 miles, 112 miles over 1, right? Over 1 times a fraction. Now, we already just did this a minute ago, miles to feet. That's like the previous problem, right? So miles is on top. I put miles on the bottom, feet on the top. 1 mile is 5,280 feet. Miles cancel. So how are we going to do this next fraction? We have a conversion from feet to inches. Now, actually, I don't think it's in the table over here, but I bet we know this, Mr.
Yeah,
Dimitrich.
we're kind of expected to know 1 foot is equal to 12 inches.
Yeah. Now, wait. 1 foot is 12 inches. I see foot on the top. So what do I need to do? How do I can write this 2 ways. I got to write it the right way, though.
You have to cancel the units, and you always put the unit you want canceled opposite. So since feet is on the top, you got to put foot on the bottom.
So I put foot on the bottom, inch on the top. Of course, there's 12 inches in 1 foot. Got it? Foot cancels. I keep going. I want to go from inches to centimeters. So what's the conversion, inches to centimeters?
Well, you have to look at the table here, and it says 1 inch is equal to 2.54 centimeters.
Okay, and again, we want to cancel off inches. So inches goes, it's on the top now. It goes on the bottom now, centimeters. and there's 2.54 centimeters in 1 inch. Now, in this case, all of the numbers are all on top. So I'm going to say 112 times 5280 times 12. I'm just saying times 2.54 gives me a one honking number, 1802465.2.8 centimeters. Now, that's not enough significant digits. Let's look at our significant digits. Here, I have how many? In 112, Mr. Dimitrowicz?
You have 3.
That's 3. This is the definition of a mile. This is the definition of a foot, so those don't count. And this has 2.54 centimeters an inch, 3 again.
3
so we're going to round to 3 significant digits. So that's to this 180. So it's going to be 180, and these are all going to be zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is that 1.8 million? It's 18 million centimeters. Okay. Or you could also write that as what?
1.8, and then times 10 to the, and if you count the number of zeros from.
Actually, not just the zeros, but the places, because the 8 counts as the place.
That's what I meant
the
to say,
7th
yes.
centimeters. Okay. And now let's do one more example.
Just to tag on here, though, if you're ever confused, a lot of the time, the number of significant figures we start off with in a conversion is the number that you end up with in a problem.
That's actually a good point.
That's not a hard rule, but I'd say, what, 90% of the time, if you're like, oh, I don't know, that's probably the way to go.
And also, when in doubt, I would recommend that you just round to 3. You can almost always be, it's always going to be, almost all the time in a chemistry class, 3 is a good number.
Love the number 3. By the way, we've been doing problems that only have 1s on the bottom, but that's not always going to be the case, Mr. Bergman, correct?
Well, that's going to come up in the next video. All right, and the last problem here is we're going to take 45.3 ounces, and we're going to convert it to grams. Now, this one is, again, we don't have ounces to grams over here on our table, but we have ounces to pounds. You guys see that? So we can go from ounces to pounds, and then pounds to grams. So what do? We write it as a fraction over 1. 45.3 OZ over 1 times a fraction. We got ounces. So how many ounces are in a pound? Mr. Dimitrowicz, from the table? This might be something people know.
It's 16 ounces in a pound.
And ounces go on the bottom. So you can count down. And now we got a number on the bottom. That's what I wanted to get at. So the ounces cancel. Yes. And now I want to go from pounds to grams. Now, the conversion, as you can see, is 450. I'm just going to round it to 454 grams in a pound. So what goes on the bottom? Pounds, right? 1 pound is 454 grams. And the pounds cancel, and we have grams. Now, this one's a little tricky on the sort of calculator work, because you have a number on the top, a number on the top, and a number on the bottom. Now, because is it associative or whatever, or distributive? I forget how multiplication, what the fancy term is in mathematics, one of those terms. But basically, you can divide, I can type in 45.3 times 454 divided by 16. Or I could just as well take 45.3 divided by 16 times 454. Basically, the rule is anything on the bottom, divide. If I had 5 things on the bottom, divide, divide, divide. So I'm going to do this. 45.3 divided by 16 times 454. And I get a big old number, 1285.39 or something like that. Like Mr. Dimitrowicz said, we've got 3 significant digits. We're going to round this to 3 significant digits. So that's going to be 1290, and that's grams. The 5 rounds the 8 up. All right, folks. Mr. Dimitrowicz, anything else from this content that we need to?
No. Just make sure that you, whenever you're setting up your tables, that you're setting up to cancel, and that you write the conversions exactly as they're written.
That's right. All right. We'll catch you next time. We'll see you soon.
Take care.